Imagine the far future of humanity, long after we and our immediate descendants have come and gone, long past the end of the era in which our species was chained to a single planet. Imagine a time when terms like artificial superintelligence, nuclear fusion, or gene editing are positively antiquated, or when they're relics of a bygone era, and when the things that have come in their place go far beyond anything that our small human minds could conceive of today. It's a pretty tough thing to do, isn't it? To try and really understand what a civilization such as that would look like, how its people would live, or whether we'd even recognize them as people at all. Imagine what even one small element of their lives might be like, and immediately you'll be struck with the awareness that you've got nothing to put around that detail, no way to picture or to understand a world so profoundly advanced past our own. But there is one tool of today's civilization, blurring the line between science and speculative fiction, that endeavors to give us a window into the far future of humanity. With it, the creator endeavored to understand, as best any person can, the way in which an extraterrestrial society might have advanced far beyond our species here on Earth. Its name is the Kardashev Scale, and although it's the sort of theoretical instrument that science currently has no way to test or validate, it's perhaps the best glimpse that our world has gotten at the star-harnessing, galaxy-bending super-civilizations that could be out there in our universe, or even in our own future. Alright, so the Kardashev Scale was the brainchild, believe it or not, of a guy called Kardashev, Nikolai Kardashev, in fact. He was a Soviet-Russian astrophysicist, just 31 years old in early 1964, when he put forward an idea at a conference in Soviet Armenia. The idea he described was one that sat somewhere between being a scientific instrument and being a cool new toy for all these science fiction writers of his era. It was a scale that intended to classify types of hypothetical advanced civilizations once they reached a level of evolution that far exceeded our own. Now, very early on, we've got to point out a core problem with Kardashev's scale, especially if we're going to discuss it with even basic respect for the scientific method. When trying to figure out how civilizations technologically advance, Kardashev was working from a sample size of 1. And for that matter, he was working with a civilization that has still only set foot on one other celestial body half a century after he first put his ideas forward. With all the kindness and empathy in the world for our fellow humans, we're not very advanced. And so it's a bit of a leap to assume that any of us really know what an advanced civilization would be like. But despite the very valid criticism that doing the sorts of theoretical extrapolation that Kardashev gave us could probably be described as outright unscientific, his system has still gotten very positive reception from the astrophysics community for generations, and it still does today. Given that Kardashev didn't have a way to study or measure civilizations advanced beyond our own, his first task was to identify a basis for his classification scale, and the one that he settled on was a civilization's rate of energy consumption. It was a sound assumption, one that's held up to this day. Kardashev assumed that as a society grew more advanced, its needs for power would increase proportionally to that level of advancement. Humans had demonstrated basically the same thing in the decades before Kardashev put forward his mechanism, and in fairness to him, we've continued to demonstrate that trend as he predicted. The scale assumed that, like human civilization, an advanced society would see its demands for power consumption rise exponentially as time went on. In addition to energy consumption, Kardashev relied on one core assumption: that the basic laws of the universe, like conservation of energy or the limit of faster-than-light travel, were unbreakable laws that every society, no matter how advanced, would have to work within. The Kardashev Scale split civilizations into 3 types, conveniently named Type 1, Type 2, and Type 3, and humanity, by Kardashev's assessment, doesn't even make the list. Instead, the fundamental requirement of a so-called Type 1 civilization is that it can access all the energy available on its planet and either consume it straight away or conserve and store it for later consumption. Perhaps somewhat generously toward his own species, Kardashev described this as a, quote, technological level close to the level presently attained on the Earth. Other scientists who've extrapolated on the Kardashev scale, of which there are many, have typically endorsed the idea that in practical terms, accessing all the energy of a planet basically means capturing all of the solar energy that reaches the planet from its parent star. In Earth's case, that's about 200 quadrillion joules of energy arriving by way of the sun every second. And for perspective, that's several thousand times more energy than human civilization consumes in the same time period. Other interpretations of the scale suggest that instead of merely accounting for solar energy, a Type 1 civilization should be able to account for all energy on a planet, from the movement of its tectonic plates to the flow of its rivers and oceans. Some variations on Kardashev even suggest a Type 1 civilization could learn to control natural disasters like earthquakes or volcanic eruptions. And if a Type 1 civilization isn't impressive enough, well, then we move on to Type 2, a civilization that's capable of harnessing all of the energy emitted by a star like ours, presumably their home star, although that need not be the case in order to hit the threshold. Using our sun as an example, that's an energy supply of about 4 decillion joules, or about 4 billion trillion joules. If that way of describing it makes it any more sensible, it doesn't. It's a huge number. Now, to harness that energy, a Type 2 civilization would presumably need to create some sort of external structure that can account for all of the energy that the star produces, and we'll talk more about those sorts of structures when we visit Type 2 in depth. And finally, after a Type 2 civilization, we can exponentially increase its energy needs several times over to arrive at the threshold of a Type 3 civilization. The energy consumption equivalent to that of an entire galaxy. Taking the Milky Way as an example, that's a figure of 400 tredecillion joules of energy at any given time, or the number 4 with 44 zeros behind it. That's a trillion times a trillion times a trillion times 100 million units of energy. In this case, multiplied by 4. At that scale of energy consumption, a civilization would be able to achieve untold wonders, and that's just the baseline threshold for inclusion. Kardashev didn't go past Type 3 on his initial scale, although we'll be discussing the implications of energy use many orders of magnitude greater than Type 3 later on in the episode. In understanding the Kardashev Scale, it's important to understand what it leaves out, and although we'll be poking a few holes in this system in a little while, there's one little oddity that we've got to emphasize up front. It is entirely possible, under the system that Kardashev laid out, for a civilization to become very advanced on a whole range of metrics without ever meeting the threshold to be Type 1. A civilization can build great generation ships and travel the stars, colonize planets in every direction, and rise to the level of technological advancement that would put modern humans to shame, but still not reach the core criterion of energy consumption that Kardashev laid out. Simultaneously, it's possible that a civilization could meet or exceed the threshold to be termed a Type 1 civilization in Kardashev's world without ever having worked out technologies like internal combustion or the internet. It's hard to imagine how that would work, but that's the problem you run into when you try to extrapolate off a sample size of 1. In fact, it's one of the key strengths of the Kardashev Scale as a tool of measurement that it doesn't insist that a civilization develops certain technologies or capabilities. If a civilization develops some mechanism to consume predetermined, gargantuan amounts of energy, then the how is, in a way, less important than the simple reality that they've grown to that level. The scale isn't prescriptive. It doesn't demand that either an alien civilization or a far future earthly civilization would be like ours. Instead, they're able to take hypothetical shapes all their own. Alright, now before we dig into all of the different interpretations and ramifications of the Kardashev Scale, we've got to do a collective thought exercise and ask ourselves the question, what does each type of civilization at each interval of the Kardashev Scale actually look like? Again, we're off in a corner of speculation where we have precisely 0 real-world examples to go on, so take everything we discuss not just with a grain of salt, but with permission to be a bit imaginative about all the different ways these civilizations could be. We'll start naturally at Type 1, the lowest and least advanced of Kardashev's 3 tiers. At current estimates, humanity is expected to graduate past the minimum threshold of a Type 1 civilization in somewhere between 150 and 400 years. One study supported by NASA's JPL, published a few years ago, lays out a concrete timeline for humanity to progress to Type 1, where, according to JPL, we'll finally hit the criteria in the year 2371. It's when Star Trek happens. Isn't that Star Trek The Next Generation? That's cool. Another paper, this one published slightly earlier, thinks a bit better of us humans and gets us there in the year 2347, so 24 years earlier than the JPL team thought. Of course, that's assuming we're able to do something else, and that's survived that long in a world plagued by weapons of mass destruction, superbugs, and approaching AI singularity, impending climate collapse, and, of course, all these celestial rocks and beams and other things that could wipe us out very easily. The NASA study we referenced isn't necessarily optimistic about our chances, but it lays out 2 stepping stones that would get us to Type 1 status, making renewable energy accessible worldwide and sharing advanced technology with all nations that are able to handle it. Neither, of course, are anywhere near guaranteed for our species. But when we move away from the specifics of the human condition and begin to imagine what a Type 1 civilization could be like in general terms, we've got to keep that same sense of optimism. Of course, there are no guarantees, but if you can learn to harness all of the energy accessible to you on your home planet, then a few things are probably also true. Your society has probably discovered some sort of technology that could be used to wipe yourselves out, whether it's something we'd recognize as a nuclear or biological weapon, or something we don't think about in weapon of mass destruction terms, or something that wouldn't even occur to us in our society. In the process of discovering that mechanism of collective self-destruction, you'd have to find a way to collectively resist the temptation to use it. In order to engage in a planet-scale effort of energy harvesting, you'd have to be able to work together across your home planet, finding a way past factionalism, war, greed, and all the other things that seem as if they prevent humans from pulling off the same feat. And you'd have to figure out how to avoid exhausting your home planet's resources wastefully in order to keep civilization intact for long enough to perform some truly impressive feats of engineering. In essence, you'd have built what theoretical physicist Michio Kaku refers to as a, quote, planetary civilization. So, what does that look like in a practical sense? Well, at the very least, it likely includes the development and widespread implementation of energy production mechanisms like nuclear fusion, and possibly even more advanced mechanisms using antimatter. Also, as it relates to energy production, humankind, or a comparable civilization, would need to vastly improve solar energy farming technology, both on terra firma and potentially by leveraging orbital collection mechanisms that soak up solar energy directly from space. And as energy gathering capabilities extend upward through an atmosphere, they'd also have to penetrate down into the soil, through the crust, and into the incredibly potent sources of geothermal heat that a planet can provide. With those capabilities to produce energy would likely come ways to store and transfer energy that go far beyond the batteries and power lines of modern Earth. Today's batteries are a known and serious limitation to human potential. But a society that can make use of all the energy available to its own planet would certainly need to work out better ways to keep and utilize what it captures while minimizing waste. And while it's difficult, if not counterproductive, to try and pinpoint these specific technologies that would allow a civilization to reach Type 1 status, it's easier to identify technological thresholds that have to meet and surpass in order to get there. Those include a complete or nearly complete departure from non-renewable fuel sources, oil, gas, and the like, or at the very least a replacement of finite natural resources with a limitless synthetic or extraterrestrial supply. There's also the realm of material science, where, based on humanity's current understanding of what will be required to achieve these sorts of feats, a society would need to figure out molecular assembly and other nanotechnological elements that would allow for innovation on a really tiny scale. Weather manipulation would almost certainly be within a Type 1 civilization's control, and with it, basic tools of terraforming, turning desert areas into fertile land, ensuring safe and tranquil coastal areas, that sort of thing. In order to coordinate societal initiatives on this scale, a civilization would likely need to figure out some sort of planet-wide, near-simultaneous communication that goes far beyond the modern internet. The implications of such an achievement range from breakthroughs in quantum computing to the development of highly advanced but benevolent artificial intelligences to the potential development of mechanisms that partially or fully integrate human consciousness itself to a wider network. Principles of universal communication, although not necessarily the establishment or agreement of a common language, would have to facilitate such a change, while modern problems like resource scarcity and international competition wouldn't just be something a civilization grows out of, they'd be something that a civilization transcends any need for. Finally, although it's not necessarily mandatory, a civilization that can reach Type 1 status would likely have expanded into at least their immediate vicinity in space to collect resources from asteroids, set up non-terrestrial methods of energy capture, and leverage any nearby moons or planets to further their goals. And it's worth noting that for a Type 1 civilization, this is just the start. The Kardashev Scale doesn't imply that a civilization reaches the threshold to become Type 1 and then just sits on its capabilities until bounding forward into Type 2. Instead, after satisfying the societal, technological, and energy capturing requirements to become Type 1, we can infer a range of advancements within Type 1 while on the path to Type 2. A growing Type 1 civilization would eventually, by necessity, develop societal needs that its home planet itself couldn't fulfill. Remember, the next interval, Type 2, requires full capture of the energy of an entire star, and building any such device that would harness that energy would almost certainly require more physical resources than a planet can provide. Expansion into space, across and to the far edges of the solar system, are thus a likely hallmark of a Type 1 civilization, as well as the development of large-scale industrial capability in space. Autonomous systems would likely need to facilitate that level of industry, robotics, independent and even self-replicating machines, and great networked intelligences that could manage such an effort, although we should emphasize again, a civilization that develops completely differently to our own might work out some other mechanism to achieve a similar result. So too can we infer that a society that's transcended things like nationhood or resource competition could achieve lofty goals as a collective, working within new types of intelligences that we wouldn't understand or conceptualize today, and perhaps fundamentally re-evaluating what it means to be a single being in a society. In the process, such a society would need to either establish firm controls over any external, artificial, parallel, or higher collective intelligence that it collaborates with, or otherwise make the decision to surrender to it. And in a portion of Type 1 societies, it's not unthinkable to suppose that civilizational development could stop rather than progressing to Type 2, not because of atrophy or societal breakdown, because of a change of ambition. Once discussions of large-scale interstellar expansion begin, a society may start to debate what's really to be achieved by this sort of expansionism, and whether another set of priorities might be more important in the end. Perhaps Type 1 societies could instead work to create a digital collective consciousness, an artificial world that relies on energy sources that could sustain it for millions or billions of years, perfect and eternal, without death for the beings that chose to enter it. Perhaps they'd give the responsibilities of development and civilizational maintenance over to machines and choose to enjoy natural lives of immense creativity, joy, and abundance. Perhaps they'd choose to devote their time and resources to expanding across the stars rather than building the means to harness the energy of an entire star, thus never becoming a Type 2 civilization, but embarking on great missions of space exploration and colonization anyhow. Perhaps they'd eventually regress through societal upheaval or lost knowledge or a change to the cosmic circumstance. Or perhaps, in some enlightened state, they'd come to consider themselves a blight on the universe and choose to end their great experiment on their own terms. Regardless, a more advanced Type 1 civilization would have the power at its fingertips to choose among a range of paths before it, and need not be slavishly devoted to the cause of expansionism. But what about a Type 2 civilization? The sort of society that does continue expanding to the point that it can harness the power of its entire home star. Remember, this represents a need for several billion, trillion joules of energy at a given time. A truly incomprehensible amount for human minds like ours, representing the power of a nuclear fusion reaction that seemingly only nature could produce. The core attribute of a Type 2 civilization is, therefore, its mechanism to harness all that stellar energy. And it is here that we find the hypothetical creation that is synonymous with Type 2 civilizations, the Dyson Sphere. This is a proposed megastructure that a civilization would construct around a star, fully sealing it off in order to collect all of the radiant energy that it emits. This sort of complete stellar energy capture is the base threshold to achieve Type 2 status, and it is theoretically feasible, although some of the physical requirements of this technology, from incredibly strong materials to an unfathomable amount of raw resources to labor, biological or artificial, to construct it all, are all so staggering that it is hard to see how a civilization could overcome each barrier simultaneously. By contrast, many theorists agree that a more likely alternative is a so-called Dyson swarm, an incredible number of smaller energy-collecting satellites in a giant cloud around the star. To build a device of this size, either via a single sphere or a collective swarm, a civilization would basically have to take apart a small planet just to get the raw material to do it, and that's assuming that they'd be able to use their resources more efficiently than we could here on Earth. With that sort of technology, a number of other technologies are implied. Incredible numbers of builder machines to assemble a sphere or swarm, plus transmission mechanisms to actually get that energy to the civilization it's meant to fuel, with little to no waste in the process. Some astronomers have postulated that by starting with a smaller apparatus, a ring of satellites for example, powering an early infrastructure to fuel the start of the building process, a Dyson swarm or sphere could be built using the harnessed energy of the early apparatus. But that Type 2 threshold is only crossed when the entire energy of that star is captured and not before. With so much energy at its disposal, a Type 2 civilization would have to be investing that energy toward goals we could hardly conceive of in today's world. The terraforming of planets and moons, the rearrangement of solar systems, the construction of artificial structures for large societies to live in deep space, and the powering of engines that could accelerate even the largest spacecraft toward something near to light speed. A civilization that can capture the energy of its star would likely have no trouble stripping down atoms asteroids en masse for their materials, creating habitable structures that work within the conditions of other, less outwardly habitable planets, and sending its explorers to far-flung star systems other than its own. The options and limitations by which captured stellar energy can be stored and used will likely dictate the precise goals and abilities of such a civilization, but at the very least, a civilization that goes to the immense trouble of building an entire Dyson apparatus will probably have a decent idea of how that energy should be used. And if the advancements of a Type 1 civilization weren't enough, the lives and experiences of beings inside a Type 2 civilization have the potential to be mind-boggling. It's about this stage that a civilization could develop the means for near-eternal life in digital form, constrained only by the lifespan of a host star once consciousness is uploaded into an artificial system. Factionalism, funnily enough, actually becomes easier to manifest in a system like this, where cultures on different planets or moons, or even in different star systems, might become more radically divergent. But other than ideology, it's difficult to imagine what such people could actually bother going to war about, especially since all inhabitants of a given system would need to share access to their single best source of energy. Even the physical form of such a species, if that species chose to retain its physical bodies at all, would probably be very different from what it had initially been, as different sects and colonies adapt to new gravities, different levels of radiation, and more. Now, we should emphasize that there's a level of variability in what an early Type 2 civilization could look like. Not only could they use a non-Dysonian energy collection system, but they could also build an apparatus around a star other than their own. Perhaps their intent would be to preserve the sanctity of their own star system while exploiting another that may not have planets worth terraforming or might be bigger and brighter. Either way, the Type 2 threshold just requires energy consumption equivalent to a sun-like star. So, how a civilization gets there is kind of immaterial. But as a Type 2 civilization grows more advanced, just like we discussed for a Type 1 civilization, it would begin to look different before ever crossing over into Type 3. Again, there is no mandate for a society to keep advancing toward Type 3 after it reaches Type 2. Depending on its priorities, objectives, circumstances, it may decide not to advance further or to pursue some other sort of advancement for any range of reasons. But civilizations that continue to evolve along the Kardashev scale within Type 2 seem as if they'd follow a relatively predictable path. Since they'd be evolving to fuel ever-expanding energy needs, and they wouldn't be able to access any greater energy source within a star system than the star itself, the next logical step is to travel to other stars. Broadly then, evolution within Type 2 will probably consist of a slow creep across a civilization's host galaxy, first capturing the energy of the nearest stars to their homeworld, and then the local stars in their cluster, and then more and more. From the outside, that might look as if a galaxy's stars are inexplicably winking out over the course of millions of years, sort of like a city going dark, district by district, during a blackout. From the inside, it would mean that such a civilization is either replicating what it did to its own star system in hundreds, then thousands, then millions of other star systems, or it might be funneling all of that energy towards some greater purpose. As for what that purpose could be, well, you can take your pick from science fiction. Perhaps the goal is to create and manipulate wormholes for faster-than-light travel, or to harness the power of supermassive black holes to preserve or send great power to some vast consciousness, or to open doors to other dimensions, or perhaps even other universes. How such an advanced civilization might understand the laws of physics, we humans could hardly guess, and they may swell to a power that would allow them to dictate those laws of physics rather than be beholden to them. Finally, one other thing is probably true about a Type 2 civilization, that it's grown past the stage of evolution where anything could destroy it except itself. Wipe out a planet or a star system or even a pocket of a galaxy, sure, but nothing snuffs out a civilization that's on its way to galactic takeover except that civilization itself. And then finally, there's a Type 3 civilization, a society that's grown so incredibly powerful that it can harness the energy of its entire host galaxy. That's power on a level that is really, really difficult to fathom, but we can at least try. A Type 3 civilization will have had to work out a few technical elements at a minimum. They'll have to have built billions of apparatuses around the stars in their galaxy, already an unbelievably impressive feat. By then, one of two things will be true. If they're still constrained by the laws of the universe as we understand them today, then they probably aren't able to coordinate or share information in any practical way. After all, if information cannot travel faster than the speed of light, then sending a message from one end of a galaxy to the other would take thousands of years. And conversely, if they are able to transmit information in real time, share the energy they harvest, and work together toward a broader purpose, then they will therefore have found some way to break past the speed of light barrier. If that's the case, then such a society will be leveraging the energy provided by tens or hundreds of thousands of stars to accomplish tasks that couldn't be achieved with energy less than that. Such endeavors might include building Dyson sphere-like apparatuses around supermassive black holes to harness their energy in the form of Hawking radiation, or to dismantle, reshape, or repurpose entire stars at a time. Probably they could even create their own stars. They might also be able to create a galactic scale version of something called a Matryoshka brain, a supercomputational network on the scale of an entire galaxy. What might the thing be capable of? Well, just pick something that sounds impossible and you can probably assume it can do the job. For living beings, surviving until such a time as a Type 3 civilization is realized would be functionally the same as achieving immortality, assuming that by this time a species has long since transcended any lasting dependence on its fleshy form. Unfortunately, there really aren't many other estimations we can make about a Type 3 civilization with even the slightest level of confidence in our own accuracy. This is about where expert attempts to imagine such a thing in detail basically reach their limit, and where science fiction descriptions of ultra-powerful societies basically have to be regarded with a feeling of, yeah, I mean, it's probably possible. If a puny little human brain can think of it, then a Type 3 civilization that has transcended our laws of physics can probably do it. While a Type 3 civilization still bound to the same universal laws we are is probably better understood as a whole galaxy's worth of Type 2 civilizations with no real ability to coordinate in a cohesive network. Now look, it's no wonder that the Kardashev Scale, in all of its methodological simplicity and all of its speculative glory, has caught on around the world. Across the astronomy community, the broader scientific community, the science fiction community, and more, the Kardashev Scale is a treasured and hotly debated idea, for good reason. So, although we've laid out the three sorts of civilizations that the Kardashev Scale predicts, Kardashev's own ideas were just the start. Since Kardashev's own era, a range of bright minds have taken his fundamental concept and spun off their own variations. And, like any good thought exercise, those variations can tell us even more about the future of civilizations. Some of the earliest riffs on the Kardashev Scale came by way of Carl Sagan, the famed astronomer and science communicator who was synonymous with research on extraterrestrial life for the latter half of the 20th century. Sagan proposed a far more precise version of the Kardashev Scale, one that sought to explain smaller variations and steps up in power consumption between Types 1, 2, and 3. On his scale, humanity was roughly a Type 0.7 civilization back in the 70s when he was putting these ideas forward. That way of classifying humanity has caught on, with current estimates placing our species somewhere between a 0.73 and a 0.75, although the implication of hundreds of types of civilization make that method a little bit less accessible. Sagan also introduced the idea of a Type 0 civilization, one that would reach a Type 0 threshold when its energy needs were that of about 1 megawatt in total at any given time. That's roughly equivalent to the burning of 100 campfires at once, and it's a useful way to conceptualize what we might call the starting point of civilization, regardless of where that civilization may be located. Alongside a Type 0 civilization, a range of thinkers have suggested Type 4 civilizations, Type 5, and even some beyond that. Those frameworks usually explain those civilizations beyond Type 3 would be able to harness the power of an entire galactic supercluster, or an entire universe, or even parallel universes or higher dimensions. Some takes on this idea suggest that those more powerful civilizations could hide or otherwise exist in some way where humanity would never perceive them while living in the very fabric of the universe all around us, thus explaining why humans wouldn't have noticed a civilization of that size. Others, most prominently the astronomer John Barrow, have postulated that instead of using more and more energy, it may be useful to classify civilizations on the basis of how tiny an object they can manipulate. Under this system, Type 1- civilizations would be able to manipulate objects around their own size, a person taking a sip of water or building a house or putting on a shirt. A Type 3- civilization could manipulate substances at a molecular level. A Type 6- could manipulate quarks and leptons. Barrow's ultimate civilization, the Type Omega-, could modify space-time itself by reaching down to manipulate the very thing that must form the essence of the universe. There are, of course, ample criticisms of the entire Kardashev Scale and all of the many riffs on Kardashev's presence. The most fundamental one is rooted in the same question as the infamous Fermi paradox. Where is everybody? If civilizations could build Dyson spheres, surely we would detect them, observing the heat signatures of stars that should be there but don't shine visible light. If civilizations were able to take over galaxies, and were doing so, then why isn't there an indication of such a thing based on the data that we observe? Some theorists disagree with the idea of measuring civilizations by their level of energy consumption rather than their technological development or the growth of their population. Others suggest that it's impractical for a civilization constrained by the laws of the universe as we understand them to grow bigger than a handful of star systems. Still others, drawing on suggestions that humans probably won't survive long enough to become a Type 2 civilization or greater, would suggest that it's probably very difficult for any civilization to make it that long once they figure out all the sorts of nasty technologies they could use to wipe themselves out. And once you start changing the fundamental nature of society, imagining them to have attributes that would ensure they didn't eventually self-destruct, you've got to question whether such a different civilization would even move its way through the Kardashev Scale. After all, what will be the point for a society that doesn't lust for conquest in the way that humans do? No matter what particular interpretation of the Kardashev Scale might suit your curiosity best, the fundamental nature of the Kardashev Scale remains the same. It is a tool to understand hypothetical civilizations, certainly, but it's also a tool to understand our own society in intimate detail. And rather than simply imagining a future for humanity, the Kardashev Scale's true value is that it gives humanity a path to get there, with a simple, straightforward way to track human progress and no prescriptions about the right or wrong way for that progress to happen over time. So, as we wrap up today's episode, it's worth devoting some time to what may be the most important question of all. How does this grand, abstract Kardashev Scale relate to us? What does it tell us about our world today and about where we might be headed? On the one hand, humanity is clearly making consistent, focused progress toward becoming a Type 1 civilization. The evidence of that progress is everywhere, starting with the most important realm of all, energy. Humanity is rapidly moving toward better and better mechanisms to capture energy from the sun, from the wind, from Earth, and more. Progress toward nuclear fusion technology is ongoing, and even conservative estimates suggest that we'll have fusion figured out by 2100. In the technological realm, the vast energy consumption needs of new endeavors like artificial intelligence suggest a real need for humans to continue finding ways to make more energy. While the world's increasingly frequent resource-driven conflicts are certainly a net negative for the people trapped in the middle, they also speak to the idea that humanity will soon settle its differences around resource scarcity the easy way or the hard way. Culturally and socially, everything from the increasingly complex internet to a trend over the last half-century toward international socioeconomic systems to the globalization of culture itself suggests that humanity is on a path toward greater collaboration in pursuit of shared goals. On the other hand, however, one could argue that humanity has entered a trend that Mikio Kaku picked up on over a decade ago, and that evidence suggests, with increasing clarity, has grown stronger ever since. That would be a phase of development where prevailing social and cultural forces move against progression toward a Type 1 society, rather than moving to facilitate civilizational evolution. The last several years have given ample reason to think humanity is an era of pushback, from a shift toward a great power competition between an America-centric and China-centric sphere, where neither side is especially likely to be the victor, to cultural xenophobia, alienation, and isolationism that makes global collaboration far more difficult. Large-scale resistance to renewable energy, efforts to create separate resource supply chains through zero-sum conflicts, and even the recent global trend toward nationalism rather than globalism are all barriers to becoming a Type 1 civilization. Or at the very least, they're barriers to getting there the easy way, quicker, and with minimal bloodshed. On top of it all, a poorly regulated and seemingly irresponsible push toward advanced artificial intelligence as soon as possible, a growing trend of antibiotic-resistant pathogens, the proliferation of nuclear weapons, and a deteriorating climate all present a risk that humanity will either wipe itself out before reaching Type 1 status or otherwise engage in a hard reset, anywhere from the pre-internet age to the Stone Age, or worse. We've said it before, and we'll say it again. There's more than one way to become a Type 1 civilization, and for a civilization to then work its way up the Kardashev Scale, there's no reason to suppose that fundamental changes to society as we know it would prevent humanity from one day reaching those milestones. There's no hard and fast rule that a civilization can't do a few hard resets before finally getting it right, and there's no clear way to define what getting it right even means. In fact, there's even a decent argument that if a super-intelligent AI wipes us all out and then works its way up the Kardashev Scale, then in a way our civilization did continue down the path of cosmic advancement. But right now, it appears that human civilization will need to work its way through a long list of growing pains if it's going to continue towards civilizational advancement on its current course. The Kardashev Scale, it's an instrument. It's cold. and unfeeling, and it doesn't bear much regard for the societal upheaval that would come with, say, a nation achieving world domination and becoming a Type 1 civilization by itself, or a superintelligent AI enslaving the human race in service to that goal. But we humans are soft, squishy things, capable of empathy and understanding, with a keen awareness of what it would mean to destroy all we know and love, even if the eventual byproduct of that process is a more advanced civilization than the one we have now. The Kardashev Scale is a human instrument. It's one that is rooted in our understanding of human civilization, but it's not a tool that presents a linear pathway to progress, world peace, human enlightenment, transcendence of all our petty concerns. Those are inferences, things that scientists, theorists, and ultimately optimists will infer to understand a pathway of civilizational advancement that doesn't actually guarantee any of it. The energy needs of a civilization predict its advancement, and at a certain threshold of energy need, we can infer the raw power that a civilization will have at its disposal. That is the nature of the Kardashev Scale. And in truth, that's the entire nature of the Kardashev Scale. The path a civilization takes, and the path that humanity takes to realize those levels of advancement, are entirely up to us. There's great freedom in that, and along with it, a profound responsibility. So let's hope that humanity can prove it's up to the task. Thank you for watching.